So just to show you what Flownex looks like when you initially launch it, it's got a very Microsoft Office ribbon feel to it. You have a list of previous projects that you've worked on, and the really nice thing that Flownex has is it comes with a very large library of demos, tutorials, and what have you. And so, and these aren't just basic, it runs the gamut from, how do I put a pipe on the page and simulate pipe flow to how do I simulate a deaerator, how do I simulate a vapor compression cycle, all of those different things. And so this is a really great start point. This comes installed with the software. So if it's your first time or if it's just been a while, it's something that you can easily refer to. And each one of these will bring you to an interactive PDF file that has all the necessary input files needed. As far as what I'm going to be doing, I'm going to be using this Flownex session. And we'll go ahead and get started. And so as far as what the goal is on this presentation, I'm going to show you what the GUI is. I'm going to talk about libraries and elements and how we simulate problems within Flownex. We'll go over running transients, show how you can visualize your network, go over some very powerful tools, specifically the designer, the optimizer, and the sensitivity analysis. We'll also show some scripting in Excel and talk about some more advanced topics like phase change, water hammer, and then at the very end I'll show you a significantly more complicated model just so you don't think that we're limited to very basic concepts within Flownex. So as far as where Flownex is used, Flownex is used in system and subsystem component simulation. And so what we're doing here is designing and integrating different thermal-hydraulic systems. And so Flownex is essentially a 1D flow solver for everything that I'm showing. Once we get into the nuclear, it's actually a 2D simulation. But what we're doing is solving for flow rates, pressures, temperatures, and heat transfers. And we're doing this for both steady state and dynamic. And so, I say it's a 1D flow solver, and I don't want you to walk away thinking that it's just a simple representation, because Flownex actually handles some very complicated physics, such as homogeneous two-phase fluids, non-Newtonian fluids, slurries, liquids, gases, gas mixtures, incondensable mixtures, and steady state dynamic. And so we get all of these different physics included, and one thing that's not listed up there is combustion. And so just because we're ignoring some very localized effect that you might be able to capture using a detailed CFD program like Fluent or CFX, we're still able to capture bulk behavior. And so if you're looking for temperatures across the cross-section in a pipe, Flownex isn't going to tell you that. But if we're concerned about what does this condition do to my overall hydraulic and thermodynamic system, Flownex is perfect for it, because you don't have to mesh it with an incredible amount of nodes and elements in order to capture that information. As far as the fundamentals are concerned, so we're handling dynamic simulations, and so we can track thermal inertia. We can create transient scenarios where we can script different events occurring, such as a valve opening or closing, a pump tripping, what have you. We can also simulate branching flow, and so that's the really nice utility within Flownex, is that if we have two elements branch off of a single node, we don't have to specify what the mass flow rate is through each branch. Otherwise, why are you using a Flownex to begin with? The reason you're using it is because you don't know what the overall system behavior is. And so Flownex will calculate the appropriate mass flow rate based off of the overall resistance of each branch. Another thing we can do is buoyancy-driven flows, and so we can include an elevation term at any node and actually track natural circulation due to density changes. As far as what we're solving for, like I said before, we're solving for, if I can grossly simplify it, we're solving for flow rates, pressures, temperatures, and heat transfer rates. But at the same time, we're also tracking quality and all sorts of other information for more complicated material definitions. As far as when we're building our network representation in Flownex, we're using nodes, elements, and boundary conditions. So pretty standard numerical analysis terminology. As far as what a very basic network within Flownex looks like, you have boundary conditions, you have a pipe element, and then you have outlet boundary conditions.